For centuries, humans have dreamed of connecting Europe and Africa with a bridge. Imagine standing in Spain, looking across the sea, and walking or driving straight into Morocco. The idea sounds simple, exciting, and revolutionary. A bridge like this would unite two continents, open massive trade routes, and symbolize global unity. Yet, despite modern technology, billions in investment, and countless proposals, no such bridge exists. Why? The answer lies in a mixture of geography, politics, economics, and science. The Strait of Gibraltar, the narrow body of water separating Spain and Morocco, is only 14 kilometers wide at its shortest point. On paper, it looks easy. 14 kilometers is less than many bridges already built, like the Hong Kong-Shanghai-Macau Bridge in China, which spans 55 kilometers. So why can we build bridges across longer distances, but not between Europe and Africa? The truth is, the Strait of Gibraltar is one of the most difficult places on Earth to build such a project. It's not just about the distance. It's about the depth of the sea, powerful ocean currents, earthquake activity, and the political situation between countries. Every factor creates a new obstacle, making the dream nearly impossible for now. Beyond engineering, the idea of a Europe-Africa bridge is symbolic. It would mean connecting the wealthier economies of Europe with the developing regions of Africa. Some argue it could reduce inequality by boosting trade, tourism, and job opportunities. Others warn it could create social and political challenges, such as migration pressure or unequal benefits. In this video series, we'll explore all the reasons why the Europe-Africa bridge has never been built, from natural barriers to man-made issues. Each script will take you step by step through the hidden facts. By the end, you'll understand why this ambitious dream remains on paper and may never become reality. The story of the Europe-Africa bridge is not just about engineering, it's about human ambition, politics, money, and our struggle with nature. The Strait of Gibraltar is one of the most unique waterways in the world. It separates southern Spain and Europe from northern Morocco and Africa. At its narrowest point, it measures about 14 kilometers. But here's the twist. The depth of the strait plunges to over 300 meters in many areas. That's deeper than most bridges on Earth could ever handle. Building a bridge isn't just about spanning the surface distance. Engineers need strong foundations that can rest on solid ground. In Gibraltar, the seafloor drops steeply, making it nearly impossible to construct supporting pillars. For comparison, most long bridges around the world, like Japan's Akashikakyo Bridge, stand in much shallower waters. Another problem is the ocean currents. The Mediterranean Sea and the Atlantic Ocean meet here, creating extremely powerful and unpredictable water movements. This constant push and pull would damage any underwater structures and make construction dangerous. Add to this the frequent storms. The strait becomes a nightmare for engineers. Then, there's the issue of tectonic activity. The Strait of Gibraltar lies near the boundary of the African and Eurasian tectonic plates. This means earthquakes are common, and any bridge would have to withstand strong seismic forces. Imagine spending billions on a structure that could collapse with one powerful quake, beyond natural challenges. The geography of the region is politically sensitive. The Rock of Gibraltar is controlled by the United Kingdom, while Spain and Morocco both have strategic interests in the area, so even choosing the exact spot for a bridge could create diplomatic tension. All these factors make the Strait of Gibraltar one of the toughest engineering locations in the world. While maps may make it look simple, just a short line connecting to continents, the reality is far more complicated. Let's dive deeper into the engineering side. Suppose for a moment money and politics were no problem. Could engineers actually build a Europe-Africa bridge? The challenges are overwhelming. First, the depth. At 300 meters or more, building support towers is nearly impossible. Most bridges require foundations drilled into the seabed, but at such depths, the costs and risks skyrocket. Alternative designs like suspension bridges would require massive anchor points on land, and cables strong enough to stretch 14 kilometers across rough seas. Second, the currents. The Strait of Gibraltar is like a giant funnel between the Atlantic and the Mediterranean. Water flows in and out constantly, creating one of the most powerful tidal systems on Earth. These currents not only endanger construction crews, but would also put long-term stress on the structure. Third, earthquakes. The strait sits near active fault lines, meaning a large earthquake could hit at any time. Designing an earthquake-resistant bridge across such a vast distance is technically possible, but the cost would be astronomical. Engineers have also considered alternatives like building an undersea tunnel similar to the Channel Tunnel between England and France. But here too, the depth and geology create enormous risks. Tunneling under 300 meters of seabed rock through earthquake zones is a nearly impossible mission. Even if technology makes it possible, the scale of such a project would take decades to complete and could cost hundreds of billions of dollars. And unlike bridges in Asia or Europe, the potential return on investment is uncertain. This is why, despite advances in engineering, no serious construction has begun. The Strait of Gibraltar simply presents a combination of obstacles that no one has yet figured out how to overcome safely and affordably. Even if engineers solve the natural challenges, politics would still stand in the way. A bridge between Europe and Africa would connect Spain and Morocco, but both countries have complex relations. Spain still controls territories in North Africa, like Ceuta and Melilla, which Morocco claims. These disputes create diplomatic tension. On top of that, the United Kingdom controls Gibraltar, a tiny but strategic territory at the mouth of the strait. Any bridge project would need cooperation from at least three governments: Spain, Morocco, and the UK, and possibly the European Union. Achieving this level of trust is nearly impossible. There are also migration concerns. Europe fears that a direct land link with Africa could lead to uncontrolled migration flows. While bridges could boost trade and tourism, they might also encourage illegal crossings. Balancing open trade with secure borders is one of the toughest challenges in modern politics. Furthermore, international investors would hesitate to fund such a project if political risks are too high. A bridge is not just concrete and steel, it's also a symbol of unity. If the countries involved cannot guarantee long-term cooperation, no company would risk billions of dollars. In short, politics is as much of a barrier as geography. Without trust, stability, and shared vision, even the strongest bridge would collapse not physically, but diplomatically. Now let's talk about money, the biggest obstacle of all. A Europe-Africa bridge would likely cost anywhere between $50 billion and $200 billion, depending on design. That's more expensive than most infrastructure projects in history. To put this in perspective, the Channel Tunnel between England and France cost around $20 billion in today's money. It's only 50 kilometers long, but the geology was simpler than Gibraltar's deep waters. The Hong Kong-Shui-Macao Bridge cost $5 billion. A Gibraltar bridge would be far more expensive. Who would pay for it? Spain and Morocco alone cannot afford such a huge project. The European Union could contribute, but its taxpayers would question spending so much money on a risky plan with unclear benefits. Private investors would demand high returns, but the traffic across Gibraltar may not generate enough revenue through tolls. The economic risks also include maintenance. A bridge exposed to storms, earthquakes, and heavy traffic would require constant repairs. Annual maintenance could run into hundreds of millions of dollars. Yes, the economic benefits could be enormous, boosting tourism, trade, and jobs, but only if the project succeeded. If it failed, it would become the world's most expensive disaster. This is why no government or company has taken the final step. For now, ferries, planes, and cargo ships remain the safer, cheaper alternatives. When discussing a potential bridge between Europe and Africa, one major factor often overlooked is the environment. While engineers and politicians debate technical and financial challenges, environmentalists warn that such a megaproject could cause irreversible damage to two of the world's most important marine ecosystems, the Mediterranean Sea and the Atlantic Ocean, the Strait of Gibraltar. The proposed location of any bridge is a natural gateway between these waters. This small stretch connects to very different ecosystems: the salty Mediterranean and the nutrient-rich Atlantic. It's home to countless marine species, from whales and dolphins to unique migratory fish. Any construction here could disrupt fragile ecosystems. The piling, dredging, and concrete structures required for a bridge would harm breeding grounds and disturb underwater life. Beyond marine life, the strait is also a critical flyway for millions of migratory birds. Birds crossing between Europe and Africa rely on this narrow passage as a resting point. Imagine massive towers and cables stretching across the horizon. It could confuse or even kill countless birds during migration. Pollution is another concern. A bridge project of this scale would require decades of heavy construction, producing emissions, oil spills, and waste. Once completed, increased traffic flow between continents could worsen air quality and contribute to climate change. Environmental groups argue that nature has its limits. Building such a structure could permanently alter tidal patterns, currents, and even the chemical balance of the seas. And if anything went wrong, say an oil spill or a structural failure, the damage would not be confined to one country. It would affect multiple nations, cultures, species. This is why environmental scientists strongly oppose the idea of a bridge. They argue that alternatives like tunnels, ferries, or greener transport options cause less harm while still connecting people. In the end, protecting the natural beauty and biodiversity of the region may be more important than human ambition. So, while the dream of linking Europe and Africa sounds exciting, the environmental risks remind us that sometimes nature is more valuable than construction. Preserving the Strait of Gibraltar may be humanity's best choice. The idea of building a bridge between Europe and Africa is not new. In fact, it goes back centuries. Many rulers, empires, and visionaries have dreamed of physically linking the two continents. But so far, every attempt has ended in failure or has remained only on paper. The earliest known idea dates back to the 19th century when European colonial powers wanted easier access to Africa. Spain and France, for example, considered a land connection to strengthen trade and military control. However, they quickly realized the engineering challenges were too great. The Strait of Gibraltar's depth and strong currents made the dream possible with the technology of that era. In the 20th century, as engineering advanced, new proposals emerged. One of the most famous came in the 1930s when Spanish dictator Francisco Franco commissioned studies for a bridge or tunnel linking Spain to Morocco. Later, during the 1970s, Spain and Morocco seriously discussed building a tunnel similar to the Channel Tunnel between England and France. But political instability, costs, and seismic risks killed the project. Private companies also made bold proposals. In the 2000s, some architects designed futuristic suspension bridges stretching across the strait, with towers taller than any building in the world. While impressive, these designs proved more fantasy than reality. Why did all these attempts fail? The answer is simple. The combination of geography, politics, and economics created barriers that no government was willing to overcome. A project of this scale requires cooperation between multiple nations. Billions of dollars in funding. Cutting edge. Engineering all working in perfect harmony, history teaches us that the bridge has always been seen as a dream rather than a practical reality. And so, despite repeated attempts, the idea remains stuck in books and studies, not in concrete and steel. If a bridge between Europe and Africa is nearly impossible, how do people travel across the Strait of Gibraltar today? The answer lies in alternatives that are already working: tunnels, ferries, and flights. Ferries are the most common mode of transport. Every year, millions of passengers and tons of cargo move between Spain and Morocco via high-speed ferries. These journeys take less than an hour and are relatively cheap compared to the cost of maintaining a mega bridge. Ferries also adapt easily to seasonal demand, unlike permanent structures that must be used constantly to justify their expense. Air travel is another alternative. Flights between major European cities and North African destinations like Casablanca, Tangier, or Algiers are frequent and affordable. For many travelers, this is faster and more convenient than waiting to cross by road. Then comes the idea of a tunnel. This has been seriously discussed for decades. Engineers envision an undersea tunnel similar to the Eurotunnel that connects England and France. However, the Strait of Gibraltar is much deeper and more unstable than the English Channel. Some experts argue a tunnel may be more realistic than a bridge, as it would avoid storms, currents, and ship traffic. In addition to these options, modern technology offers virtual connections. Improved internet, shipping routes, and aviation already link the continents without the need for a physical bridge. When we look at these alternatives, we see that the dream of a bridge may not even be necessary. Humanity's already found ways to connect Europe and Africa. Instead of building something risky and expensive, perhaps improving ferries, flights, and tunnels is the smarter path. As technology advances, many wonder, could a bridge between Europe and Africa ever happen in the future? The honest answer is maybe, but it would require breakthroughs in engineering, politics, and environmental science. Some futurists imagine floating bridges or ultralight materials that could span the Strait of Gibraltar without massive towers. Others envision hybrid solutions, partial tunnels combined with suspension bridges. With modern AI, robotics, and renewable energy, the impossible may one day become possible. Political cooperation would also be essential for a bridge to work. Europe, Africa, and international investors would need to collaborate closely. This means solving border disputes, migration issues, and trade policies. In today's world, such unity is rare, but not impossible. Economically, the cost remains a huge obstacle. Experts estimate it could take hundreds of billions of dollars to build and maintain, unless both continents see a clear economic benefit. No government is likely to fund it. However, if global trade shifts or new markets open, the project might regain interest. Finally, environmental concerns must be addressed. Future construction methods may be more eco-friendly, reducing harm to marine and bird life. If technology finds a way to build without damaging nature, opposition may soften. So, could it ever happen? Perhaps. Human history is full of once impossible projects: flying machines, space travel, and undersea tunnels. The dream of a Europe-Africa bridge may one day join that list. But for now, it remains a distant possibility, waiting for science, money, and politics to align. After exploring all aspects: geography, engineering, politics, economics, environment, history, and alternatives, we reach the final conclusion. There is no bridge between Europe and Africa, because the challenges simply outweigh the benefits. The Strait of Gibraltar is not just a body of water. It is a natural fortress with strong currents, deep seabeds, and constant seismic activity. Building here is a gamble with nature itself. Beyond geography, human factors play an even bigger role. Nations must trust each other, share enormous costs, and agree on migration and trade issues. But history shows us that political unity between Europe and Africa has always been fragile. Without absolute cooperation, a megaproject like this is doomed from the start. Even if those challenges were overcome, environmental risks remain. The damage to ecosystems, birds, and marine life could be permanent. In a time when climate change is already a global crisis, adding such a massive construction project may do more harm than good. At the same time, alternatives like ferries, flights, and possible tunnels already provide effective solutions. Humanity has learned that connection does not always require concrete and steel. Sometimes, smaller, flexible systems are better than one giant, risky project. In the end, the idea of a bridge between Europe and Africa symbolizes human ambition. It represents our desire to connect, to conquer nature, and to dream big. But ambition must be balanced with reality. And the reality is that for now, the bridge remains a dream, a story told in proposals. It's not in stone and metal. Perhaps one day, with future technology and global cooperation, this dream may come true. Until then, Europe and Africa remain close. Neighbors separated by just 14 kilometers of sea, yet divided by challenges far greater than distance.